In this chapter, we studied Unit 2nd, Trigonometry, Unit 2nd, Trigonometry, Part B. So, first upon, we know that if a function f from a to b is 1 1 and on to is 1 to 1 and on to then function g which associate elements y belong to b to 1 and 1 and only one element x belong to a such that y is equal to f of x, then g is called inverse function of f. And denoted as g of y is equal to x. It rewritten as g is equal to f inverse and x is equal to, this is inverse f inverse, and x is equal to g of y. Hence x is equal to g means f inverse. Hence x is equal to f inverse of y. If y is equal to f of x and x is equal to g of y are two functions such that f of g of y is equal to y and g of f of x is equal to x, then f and g is said to be inverse function of each other. Then we draw this chart. In this chart there are six column. This is function, then restricted function, range of function, and inverse function. This is function, restricted domain, restricted domain of the function, ब्रॅकेटमध्ये रेंज, then here range of function means domain of inverse function, then this is inverse function. The function is sine, cos, tan, cot, sec and cosec. So restricted domain is minus pi upon 2 plus pi upon 2 and cos 0 to pi, then minus pi upon 2 here minus pi upon 2 minus 0 here 0 pi minus pi upon 2 is the restricted domain, then minus pi upon 2 minus 0. Then range of function is minus 1 to 1. Here minus 1 to 1. R is the real number. Then R minus 1 1. Then R minus 1 1. Then inverse function is sine inverse, cos inverse, tan inverse, cot inverse, sec inverse and cosec inverse. Then next point is definition of inverse trigonometric function. If sin theta is equal to x minus 1 less than equal to x less than equal to 1, where minus pi by 2 less than or equal to theta less than or equal to pi by 2, then theta is called inverse sine of x. Written as theta is equal to sine inverse. Then, for example, suppose if sine 30 degree is equal to 1 by 2, then sine inverse of 1 by 2 is equal to 30 degree, but 30 degree is the pi upon 6, means 180 upon 6 is 30 degree. Then sine inverse of x is the inverse function, is the inverse sine function. Then first note is sin x inverse is equal to 1 upon sin x, and 1 upon sin is equal to cosec x is not equal to sin inverse of x. And second is if sin 45 degree is equal to 1 upon root 2, then sin inverse of 1 by 2, 1 by root 2 is equal to 45 degree. 45 degree means pi upon 4. Then if cos 30 degree is equal to root 3 upon 2, then cos inverse of root 3 upon 2 is equal to 30 degree, or pi upon 6. 30 degree means pi. Then if tan 45 degree is equal to 1, then tan inverse of 1 is equal to 45 degree, or 45 degree means pi upon 4. Then next point, get properties or relation. Properties or relation of inverse trigonometric function. So first property 1. Property 1. First property is sin inverse of x is equal to cosec inverse of 1 upon x, where mod of x greater than equal to 1, and cosec inverse of x is equal to sin inverse of 1 upon x, where mod x greater than equal to 1. Then second property is cos inverse of x is equal to sec inverse of 1 upon x, where mod x greater than equal to 1, and sec inverse of x is equal to, this is the property, cos sec cos inverse of 1 by x, mod x greater than equal to 1. And third property is tan inverse of x is equal to tan with the cot inverse of 1 upon x, where x greater than 0, and cot inverse of x is equal to tan inverse of 1 upon x, sin असेल तर cosec sin cosec sin, cos असेल तर sec येणार, tan असेल तर cot inverse. So how to prove this property? So for prove this property, first property, let Sine inverse of x is equal to theta is the first. Then x is equal to sine theta. Inverse cancel होणार. Hence x, but sine theta is equal to 1 upon cosec theta. So sine theta is equal to 1 upon cosec theta. But hence cosec theta इथे लिहिला cosec theta. So cosec theta is equal to 1 upon x. Hence theta is equal to cosec inverse of 1 upon x. So from 1 and 2, theta is sine inverse of x theta and theta same here. So sine inverse of x is equal to cosec inverse of 1 by x. And cosec inverse of x is equal to sine inverse of 1 by x. Hence first property is proved. Then we give the second property. How to prove second property? Let cos inverse of x consider theta, which is first equation. Hence x is equal to cos theta. But cos theta is equal to 1 upon sec theta. Means cos theta is equal to 1 upon sec theta. Hence sec theta is equal to 1 upon x. Hence theta is equal to sec inverse of 1 upon x. This is second. So from 1 and 2, theta same is, so cos inverse of x is equal to sec inverse of 1 upon x, and similarly sec inverse of x is equal to cos inverse of 1 upon x. Then we prove the third property. Let tan inverse of x is equal to theta is the first equation. Hence x is equal to tan theta. But since tan theta is equal to 1 upon cot theta, hence cot theta suppose इथे घेतला तर काय होणार 1 upon x. Hence theta is equal to cot inverse of 1 upon x. This is second equation. And from 1 and 2, theta same, so tan inverse of x is equal to this. So tan inverse of x is equal to cot inverse of 1 by x, and similarly we prove that cot inverse of x is equal to tan inverse of 1 by x. Then we write second property. Property second. A first property is sin inverse sin theta is equal to theta, where minus pi by 2 less than equal to theta less than equal to pi by 2. And second property is cos inverse of cos theta is equal to theta, where 0 less than equal to theta less than equal to pi. Third property is tan inverse of tan theta is equal to theta, where minus pi by 2 less than equal to theta less than equal to pi by 2. Then fourth property is cot inverse of cot theta is equal to theta, where 0 less than or equal to theta less than equal to pi. And next property sec inverse of sec theta is equal to theta, where 0 less than equal to theta less than equal to pi and theta not equal to pi by 2. Then last property cosec inverse of cosec theta is equal to theta, where minus pi by 2 less than equal to theta less than equal to pi by 2 and theta not equal to 0. So first upon we then next property is property B. First property sin inverse of x is equal to x, where minus 1 less than equal to x is equal to 1. And second cos inverse of x is equal to x, where minus 1 less than equal to x less than equal to 1. Then third property tan inverse of x is equal to x, where x belong to R. Then cot inverse of x is equal to x, where x belong to R. Then next property sec inverse of x is equal to x, where x greater than equal to 1 and x less than equal to 1. Then last property cosec inverse of x is equal to x, where x greater than equal to 1 and x less than equal to 1. Then we prove this second property. Then proof. So first let sin theta is equal to x is the first equation. Hence theta is equal to sin inverse of x. Hence theta is equal to sine inverse of, but here x is equal to sine theta. So x च्या ठिकाणी sin theta पुट करू. Since x is equal to sin theta, hence sine inverse of sin theta is equal to theta is the proved. Hence proved. This is proved. Similarly, we can prove all the results. सर्व रिझल्ट्स आपण सिमिलरली प्रूव्ह करू शकतो. सो देन रिमेनिंग रिझल्ट प्रूव्ह करा. देन नेक्स्ट प्रॉपर्टी इज प्रॉपर्टी थर्ड. फर्स्ट प्रॉपर्टी इज साइन इनवर्स ऑफ माइनस एक्स is equal minus sine inverse of x. Second property is cos inverse of minus x is equal to pi minus cos inverse x. Then third property, tan inverse of minus x is equal to minus tan inverse of x. So first we prove this property. So for this property proof, let consider sine inverse of minus x is equal to theta. Theta consider करायचा. This is first equation. Hence minus x is equal to येणार sin theta. इनवर्स आहे ते गेल्यावर sin theta. So x is equal to काय येणार minus sin theta. Minus sin इथे जाणार. Hence x but minus sin theta is the sin minus theta. Since sin minus theta is equal to minus sin theta, hence minus theta is equal to काय येणार sin inverse of x by definition of inverse function. By definition of inverse function, then multiplied by minus 1 on both sides. Both sides ला -1 ने मल्टिप्लाइड केलं तर मायनस मायनस प्लस थीटा and here -1 into sin inverse of x. This is second equation. And from 1 and 2 काय ना sin inverse of minus x is equal to, and here from 1 and 2 sin inverse of minus x is equal to sin inverse of x. Hence first property equal to minus sin inverse of x. Hence first property hence proved. First property is proved. Then we prove second property. Here second property is cos inverse of minus x is equal to pi minus cos inverse of x. Let Consider cos inverse of minus x is equal to theta. This is first equation. Hence minus x is equal to cos theta, because by definition of inverse function, then x is equal to minus cos theta. But we know that cos pi minus theta is equal to minus cos theta. Hence minus cos theta आपण कसं लिहू शकतो, तर cos pi minus theta is equal to minus cos theta. Hence pi minus theta is equal to cos inverse of x by definition of inverse function. Hence theta is equal to pi minus, इथे माइनस प्लस होना प्लस, so pi minus cos inverse of x. This is second equation, and from 1 and 2 we write down this equal to this. Hence from 1 and 2 cos inverse of minus x, theta theta same है, so cos inverse of minus x is equal to pi minus cos inverse of x. Okay, then we prove third property. Right, third property is tan inverse of minus x is equal to minus tan inverse of x. So let consider tan inverse of minus x is equal to theta. This is first equation. Hence minus x is equal to tan theta. By definition of inverse function minus x is equal to tan theta, means x is equal to minus sign it is on, so minus tan theta. But since tan minus theta is equal to minus tan theta, means minus tan theta means tan minus theta. Hence minus theta is equal to tan inverse of x, since by definition of inverse function this is second equation, and from 1 and 2, hence then multiplied minus 1 on both sides. याला minus 1 ने मल्टिप्लाइड केलं तर मायनस मायनस प्लस थीटा and is equal to minus tan inverse of x. And from 1 and 2 we write down theta same hai, so tan inverse of minus x is equal to minus tan inverse of x. This is third property is proved. Then we studied property 4. So first property is sine inverse of x plus cos inverse of x is equal to pi upon 2, and second property is cosec inverse of x plus sec inverse of x is equal to pi by 2, and third property is tan inverse of x plus cot inverse of x is equal to pi by 2. Then we prove first property. Let consider sine inverse of x is equal to theta. This is first equation. Then x is equal to काय ना sin theta. Since by definition of inverse function, but we know that cos pi by 2 minus theta is equal to sin theta, means x is equal to sin theta ऐवजी आपण cos pi by 2 we write cos pi by 2 minus theta. Hence cos inverse of x is equal to pi by 2 minus theta by definition of inverse function. Then here theta minus आहे ते गेलं plus theta plus cos inverse of x is equal to pi by 2, but we consider theta is equal to sin inverse of x, and sin inverse of x plus cos inverse theta ऐवजी sin inverse of x is equal to pi by 2. Hence this first property is proved. Then we prove second property. This property, but let consider cosec inverse of x is equal to theta. This is first property. Hence x is equal to cosec theta by definition of inverse function. Hence, but we know that sec pi by 2 minus theta is equal to cosec theta. Hence cosec theta means sec pi by 2 minus theta. But by definition sec inverse of x is equal to pi by 2 minus theta by definition of inverse function. So but here minus theta, here theta get here, so it is plus theta, plus is sec inverse is the pi by 2, but we consider theta is equal to cosec inverse of x plus this sec inverse of x is equal to pi by 2. Hence we prove this property. Then we give third example. Let consider tan inverse of x is equal to theta is the first property. Hence by definition of logarithm x is equal to tan by definition of inverse function. but here tan theta is equal to cot pi by 2 minus theta is equal to tan theta, hence x is equal to tan theta is the cot pi by 2 minus theta, hence cot inverse of x is equal to pi by 2 minus theta. By definition of inverse function, hence here minus sign, here we get plus sign, theta plus cot inverse of x is equal to pi by 2, but theta is the tan inverse of x, hence tan inverse of x plus cot inverse of x is equal to pi by 2, hence this third property is proved.